Hello, welcome to my poster. I'm Stella. Today I'm going to talk about surface attitude judgments in monocular and stereo textures, a method evaluation. Bombarded with various visual input, we humans can still judge surface attitudes, which is critical to our survival. Moreover, we can judge the attitude of surfaces in both ecologically valid 3D environments as well as 2D images without binocular disparity. In this study, we aim at comparing methods for surface attitude judgments so that future studies can use our work as a guidance for their choice of methods. The figure on the right represents how we describe surface attitudes in our study. Slant is the degree to which the surface is deviating away from the frontal parallel. In this figure, the further the gauge figure is away from the center, the more slanted it is. Tilt represents the direction of the slant. For example, these gauge figures are different in slant but share the same tilt. In our study, we used patterned artificial surfaces for our observers to judge. These surfaces consisted of randomly oriented squares providing strong perspective cues. We have three presentation conditions. In the monocular condition, observer's non-dominant eye was patched. In the binocular condition, both eyes were presented with the same artificial surface. The dichoptic condition presented a pair of stereo images to the two eyes respectively. We evaluated three surface attitude judgment methods in our study. We used gauge figure, which consists of a circular shape surface and a stick perpendicular to that surface. Participants were instructed to place the surface on the artificial surface. We presented this gauge figure in perspective only. Here, we will call it 2D gauge figure. Perspective plus disparity, we'll call this our 3D gauge figure. Moreover, we have a dial method where observers controlled two dials to represent slant and tilt respectively. This method is perspective and disparity free. Here's the results we got from a single participant. Each figure is the observer's response as a function of the ground truth. If our observer is accurate in each individual judgment, we would expect all the dots falling on y equals x, which is the red line in each figure. As you can tell, this observer is almost perfect on his response to tilt. Most participants had a similar pattern with this participant. However, when it comes to slant, the slant responses varied across different conditions. We will analyze this further. First of all, we did a correlation analysis for each condition. The slope and intercept can also show us the response pattern in each condition. As you can tell from the data, our gauge figure method showed higher correlation in dichoptic presentation condition than the binocular presentation condition. The dial method with binocular presentation appeared to be the highest in correlation coefficient among all other binocular presentation conditions. On the right, you can tell in both binocular and monocular conditions, the dial method appeared to have a higher correlation coefficient. To understand the response pattern, we looked at the estimated slope and intercept. It appeared that The high correlation in dial method is a result of overestimation of the high slant and underestimation of the low slant. Then in our gauge figure method, participants tend to overestimate the slant. The degree of the overestimation is higher when the surfaces were less slanted. Overall, the response pattern was the closest to ground truth when using the dial method to measure monocularly or dichoptically presented surfaces. We also did analysis for the reliability of each condition. Reliability, the root mean square of the difference between observer's response and fitted responses from the correlation analysis. This measure will tell us the level of inconsistency in observers' responses to the same ground truth. The gauge figure methods are more reliable than the dial method. Compared to binocular presentation condition, monocular presentation can increase the reliability of responses. So, unlike slant, tilt judgments were accurate and reliable. When measuring the slant of a dichoptically presented surface, the 3D gauge figure provides the most reliable measurement. When measuring the slant of a surface in 2D image, presenting it monocularly will increase reliability compared to presenting the images binocularly. If a researcher hopes to get better response pattern and can afford lots of repetition, we here recommend the dial method. However, if the researchers want more reliable results and better trial-by-trial responses, then we would recommend 2D gauge figure method. Thank you for your attention.